Gravitation. Now this chapter has historic importance also. This chapter has historic importance also. Interestingly, this law related to gravitation was given by Newton, and that was given around 1600. Okay. Now the important point is that we were using gravitation, we were observing gravitation in our day-to-day life for so long, correct? But we did not know that actually gravitation is acting. We did not know that gravitation is acting, correct? So even without knowing, we were using gravitation and we were facing the consequences of gravitation. So Newton was the first person who formulated how it acts. He gave formula, he did experiments on that, and then he gave us universal law of gravitation. All right, universal law of gravitation. So Newton gave your whiteboard is, it has become slow nowadays. It takes time to start. So let me tell you the story in the meantime. So what happened? Newton was a young boy and he was studying in a university. Okay. So when he was studying in university, there was an epidemic. Okay. And that epidemic was plague. You can imagine that it would be quite similar to the pandemic kind of situation, which is small. So in that epidemic that was caused due to mouse, okay, rats basically. And in that
Rats.
epidemic, what you rats, yeah. So in that epidemic, what used to happen? No, people die in bulk. Bulk means it spreads very quickly and people die. So what was the method to stop the spread? That there won't be people, there won't be spread. So they decided that the university should be shut down and all the students should be sent back to their places so that they will remain safe. And they were told that whenever we'll call you back, you can come back till the time you enjoy your holidays. So Newton was amongst those who went back to his place, but he was Newton. All the day he used to study, and that too without online classes. So all the day he used to study because he was Newton. So his mother was quite annoyed to see him studying whole day. So one fine day she said, "What are you doing? All the time you are studying. Go back." Someone's mic is unmuted. Please mute
Your
it.
voice is echoing, sir.
Because someone's mic is unmuted.
My voice is not clear.
Because someone's muted. Okay. Is it clear?
So your voice is not clearly audible.
Is it
Yes,
audible?
sir, it's breaking.
Yes, so it
Yes,
is
it's
breaking.
working.
Is it audible now?
Yes, sir.
Yes, sir.
Okay. So what I was telling you, that his mother told him to go and have some fun, do some, play some games or something. But as he was Newton, he went out with his books and started studying beneath a tree. He was sitting under a tree, and that was an apple tree, and he started studying there also. So while he was studying, he heard a sound that something has fallen. So when he looked around, he saw that there was an apple which was lying close to him, and that sound was due to that fallen apple. Now, if an ordinary person would have been there in place of Newton, that person would have thought whether to eat that apple or not, or if he is eating, whether he should wash it or not. Correct? So, such kind of thoughts would have arisen in an ordinary person like us. But he was Newton, and because of that, what he thought, why this apple has fallen downward only? Why this apple has fallen downward only? That was the thought which he got. Okay, and when a person like Newton gets some question, he doesn't stop with the question. He tries to find the answer to such questions. And when he tried to find the answer to that question, he developed the universal law of gravitation. So, universal law of gravitation. Okay. So, what is universal law of gravitation? According to this law, according to this law, every massive object, every massive object attracts another massive object, attract another massive object by virtue of their mass. Basically, what is causing this force? It is the mass of the objects which is causing this force. It is the mass of the object which is causing this force. All right. So suppose if m1 and m2 are the two objects which are kept at separation r, if m1 and m2 are the two objects which are kept at separation r, then if m1 comma m2 are the two objects kept at separation r, and capital F is the gravitational force acting between them, then F is proportional to product of the two masses. So F is proportional to m1 into m2. F is proportional to inverse of square of distance between the two masses. So F is proportional to 1 upon r square. And when you club these two, so from 1 and 2, you get F is proportional to m1 m2 upon r square. And when you remove the
So this product,
proportionality, you get F is equal to g m1 m2 upon r square. Okay. Then you get F is equal to g m1 m2 upon r square. All right. So this is the force acting between the two masses. This is the force which is acting between the two masses. All right. All right. Okay. So here G is universal. Here G is universal gravitational constant. Here G is universal gravitational constant. So value of G is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. Newton meter square upon kg square. If you see the dimensions of G, it is Newton is m1 L2 T minus 2 m1 L1 m1 L1 T minus 2 into L2 upon m2. So that gives us G is equal to m minus 1 L3 T minus 2 m minus 1 L3 T minus 2. Okay, so this is the dimensions of G. You should remember that also. All right. Now there are some key points. There are some key points. Number one, this force is always attractive. This force is always attractive. Number two, this force does not depend on this force does not depend on medium between the masses. Medium between the masses. Number three, it is a long range force. Number four, it follows inverse square law. It follows inverse square law. Number five, it is a central force. Number six, it is a central force. Number six, it is a conservative force. Number seven, it's a conservative force. Then next is it is the weakest force. It is the weakest force. Number 8. It is mediated by graviton. It is mediated by graviton and so on. We have written all these points when we studied 4 fundamental forces in nature. All right. So let us move further. Question. This is 50 kg. This is 50 kg and the separation is 1 meter. Find force acting. Find force acting between the two masses. Find force acting between the two masses. Is potential. So F will be G m1 m2 upon r square, and okay,
So your voice is cracking.
comes just a second. Now
So still cracking.
So still cracking.
this comes out to be 16675 into 10 to the power minus 11, and that can be written as 1.6675 into 10 to the power minus 7 Newton. So this is the value of F. Okay, how many of you got that? How many of you got it correctly? Okay, okay. Please write further. Gravitational force follows gravitational force follows principle of superposition.
Excuse me, sir.
Yes,
Sir, your voice is not clear.
it should be clear
Yes,
now.
sir, it's cracking.
So it cracked.
Yes, sir. Even the screen is lagging a lot.
So again it started cracking.
What to do then? Is it clear now?
Yes, sir. Now it's clear again.
Yes.
Okay. So what I am saying is gravitational force follows principle of superposition. Now what does it mean? Suppose at some point one force is F1, one force is F2, and this will be vectors, and theta is angle between these two. Okay. So at any point, if at any point two forces are acting simultaneously, then their resultant force will be vector sum then their resultant force will be vector sum of the two forces. Okay, then their resultant force will be vector sum of the two forces. So this is the principle of superposition. So F resultant will be F1 plus F2. If there are more number of forces, then it can be further also. All right. So this is principle of superposition of vectors or forces basically. So let us solve some question based on this question. This is M, this is
Sir,
M,
please spell out it.
and this
Excuse
is
me,
M.
sir.
Yes,
The screen was lagging, so can
So could you please?
scroll up.
Find net gravitational force acting on A and B. Please find everyone. Okay, everyone, enough time given. Pay attention. For A, as the force will be attractive, B will be exerting force like this. So this will be FB or force due to B, and C will also exert force in the same direction. Okay. So force on A. So FA will be, now how much is the separation between A and B? So that is A, this GM square upon A square, plus how much will be force between A and C? So this will be GM square upon 2A whole square. So this gives us GM square upon A square, 1 plus 1 by 4, 1 plus 1 by 4, and that becomes 5 by 4 gm square upon a square, and the direction will be this, and direction will be this. Okay, so this is on A. This is on A. If you have any doubt, you can tell. All right. Now force on B. For B. So if you talk about B, everyone please pay attention. So this is A, this is B, and this is, and the separation, this is A and this is 2A. This is 2A. Just a second. Force on A, this should be, just a second. Total distance was 3A. So this will be, yes, yes, yes. So this will be 9, and that gives you 10 by 9. That gives you 10 by 9. Okay. This will be the answer. This will be the answer. How many of you got that? How many of you got that? How many of you got that? Okay. Now let us talk about B. So on B, on in this direction, but C force will be in this direction. So F net on B, yes, net force, but you can say FB is equal to gm square upon a square minus gm square upon 2a whole square. All right. So gm square upon a square comes out to be common, 1 minus 1 by 4. So FB comes out to be gm square upon a square. 1 minus 1 by 4 is 3 by 4. And the direction will be this. The direction will be this. How many of you got that? How many of you got that? Can you hear me? Can you hear me, everyone?
Yes, sir. Yes,
So your
sir.
voice is so clear.
Okay. Okay. Next question. So there are three masses. There are three masses. A. Separation between them is A only.
So could you please scroll up the screen?
A. So the question says this point is A, this point is B, this point is C. Find net force acting on mass M kept at A. Basically, this is small m, this is small m, and this is small m. So please find. Okay, everyone, enough time given. Please pay attention. So basically, the particle which is kept on point A, a force will be acting like this and in this direction. So basically, F1 and F2. So F net on A will be F1 vector plus F2 vector. F net will be F1 vector plus F2 vector. Now, how much is magnitude of F1 and F2? F1 is equal to F2 in magnitude, and that is equal to gm square upon a square. How much is angle between them? So angle between them is 60 degree. Why? Because it is an equilateral triangle. So F net will be under the root of F1 square plus F2 square plus 2 F1 F2 cos 60, and that becomes, I'm calling this as F. F1 is equal to F2 is equal to F. So this becomes F square plus 2F square into 1 by 2, and this by 2 got cancelled. So this F net comes out to be root 3F, and this becomes root 3 gm square upon a square. So this is the value of F net. This is the value of F net. This is the value of F net. Root 3 gm square upon a square. Any doubt, any question? Any doubt, any question, anyone? Okay. One thing which you should ask, sir, what will be the direction of net force? So it will be along the angle bisector because both forces are equal. So this will be your F net. This will be your F net along the angle bisector. And why along angle bisector? Because both forces are equal. Because both forces are equal. Next question. Please pay attention. So there are 4 masses this time, and on each corner we are putting a mass m,
So can you just scroll up?
m, m, and this is a, this is a. Question says find net force find net force acting on mass m kept at point A. Find net force acting on mass m kept at point A. Okay. Please find everyone. Please give me the answer. Yash is saying 2gm square upon a square. It is wrong, Yash. Mangesh is saying 2gm square upon a square. It is wrong, Mangesh. Padma is saying 2gm square upon a square. Wrong, Padma. Everyone, please get the answer quickly. Okay, everyone, let's not waste time. Pay attention. On this object, on this object, F1 will be acting in this direction. F2 will be acting on this direction. And F3 will be acting on this direction. So there will be three forces, F2 and F3. So how much is F1? That is also equal to F2, and that is equal to gm square upon a square. And F3 is equal to gm square upon root 2a whole square. So that comes out to be gm square upon 2a square. All right. Now the problem which we are facing is F1, F2 and F3, all three are in three different directions. F1, F2 and F3, all three are in different directions. So let us find the resultant. So resultant of F1 and F2, we are calling it F12. Resultant of F1 and F2, and that is F12, and that will be under the root of F1 square plus F2 square plus 2F1 F2 cos 90. So this becomes 0. This becomes 0. Where is whiteboard? Whiteboard is stuck. Tomorrow, your only two classes will be there. One will be physics and one will be geology. Okay, so math students have slight party tomorrow because only one class of physics. Okay, for bio students, physics and geology.
So the ESIP one or the coaching one?
ESIP 1.
Okay, sir.
Okay. This whiteboard is stuck.
Sir,
Yes.
so tomorrow there'll be no chemistry class
No, chemistry class cannot happen tomorrow.
and the maths one.
Maths practice will be there.
Okay,
Yeah.
okay, sir.
Okay.
Excuse me, sir.
Yes.
So physics class will be at 8:30 only, no?
Yes, tomorrow 8:30.
Okay, thank you, sir.
Hmm. This whiteboard is stuck. What to do? Hmm. These are, world's best technologies. Microsoft have developed that. Correct? It is restarting, Daryl. But still, it is taking too much of time. What it will do? Window button plus T.
So it will bring the desktop.
Hmm. You want me to close the class, right? I won't let you do
No, sir.
this. So basically, again it is stuck after reaching here. Yes. So whatever we have written on this, it has been gone. Anyways, no problem. I'll write it again. So F1, which was acting in this direction, F2, which was acting in this direction, and F3, which was acting in this direction. So F1 is equal to F2 is equal to, let's say, F, and that is equal to gm square upon a square, and F3 was gm square upon root 2a whole square, and that was gm square upon 2a square. Correct? So resultant of F1 and F2, so that will be called F12. Again the screen is stuck. Resultant of F12 will be F12 It's not moving at all. It is again stuck. It is stuck again. What to do? Everyone, please pay attention. Let me discuss this without writing. So what I am saying is that resultant of F1 and F2, and these two forces F1 and F2 are right angle. So that will be under root of F1 square plus F2 square. So that resultant will be basically, I am giving you direct answer, root 2 gm square upon a square. That will be root 2 gm square upon a square. And coincidentally, the direction of F12 is along F3. Direction of F12 is also along F3. So what you can do now, the resultant of all three forces, please write F resultant. The resultant of all three forces, and what are you calling it? F resultant. Can you see now?
No, sir.
No, sir, it's the same.
Here it is allowing me to write.
Your voice is cracking, sir.
Hmm.
Your voice is cracking.
Yes, sir. Yes.
Okay. So this is the answer. This
So
is the
now the screen started moving.
yes. Please note. This is the direction of resultant. Basically, this is the value of resultant force. This is the value of resultant force. Please note.
Excuse me, sir.
Yes,
So the direction of resultant of F1 and F2 is along F3, no?
along the diagonal. Yes,
Okay,
your
sir.
F12 is also in this direction, along the diagonal. Okay.
Excuse me, sir.
Yes.
Sir, why are we not taking cos 90?
Cos 90,
Yes, sir.
because cos
Why?
90 is 0. Hello.
Okay, sir. Yeah.
Cos 90 is 0. If you want to take 0, you can take 0. All right.
Yes, sir. Got it. Yeah. Thank you, sir.
Okay. Welcome. Next question. This question I am giving you in homework. This question I am giving you in homework. And again there are masses M, 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 and this point is A. All distances are small a. All distances are small a. And the question says find net force acting on mass M kept at point A. Okay, so this is the question for you to solve in homework. Okay, next question. And in this question there is a rod, uniform rod. Mass of the rod is M and length is L. Mass of the rod is M and length is L. And then there is a point mass small m, and that point mass is at a distance small a. That point mass is at a distance small a. Okay. And the question says find force acting on small m due to capital M. That is the question. Please solve. That is the question. Please solve. Done. Everyone, pay attention. Enough time given. In this question, there is a uniform rod. We don't have a point mass. We don't have a point mass. So the prerequisite to find or calculate force using Gm1 m2 upon r square is slightly problematic in this because we don't have a point mass. So what we are doing, we are going at a distance x from here and considering an element of length dx. We are going at a distance x from point mass. I'll be writing those words also. So we are going at a distance x from point mass and considering an element of
The screen is
length
frozen.
Yes, sir. The
dx.
screen is frozen.
Yes, sir.
Frozen.
If dm is mass of element, then df will be g into dm into small m upon x square. df is equal to g into dm into small m upon x square. Now the question arises is how much is the value of dm? Pay attention. We are going to apply unitary method. So by unitary method, in L length, mass is capital M. So in unit length, mass will be m by L. In dx length, mass, so dm will be mass per
The
unit
screen is
length
frozen.
into dx. It is not frozen. So
Yes,
in
sir, the
Can you
screen
dm,
is
scroll up?
frozen.
I can
Frozen.
see the screen. I can see the screen in mobile,
Said
separate
loads.
account.
So scroll up.
Sir, it takes a lot time for it to come back. So by the time it comes, you're speaking about something other point.
Okay. So again by unitary method in L length mass is m. You can see that by arrow. So in unit length mass will be m by L. So in dx length mass will be, so dm is equal to m by L into dx. Now df is equal to g into dm. dm is how much? M by L into dx into small m upon x square. So if you rewrite it or you can readjust it, that becomes g capital M small m upon L into dx upon x square. So if we integrate it, so f will be integration df will be g m by L will be outside integration x to the power minus 2 dx. Now limit. So your first element will be at a distance a, and last element will be at a distance of a plus l. So your limit will be from a to a plus l. Now this further becomes g capital M small m upon L, and x to the power minus 2 dx will be minus 1 upon x. Okay, and limit is from a to a plus L. Limit is from a to a plus L. So now when we are going to put limits, so it will be g capital M small m upon L, minus is taken outside, 1 upon a plus L minus 1 upon a. So when you simplify this further, minus is gone inside, so g capital M small m upon L, this becomes 1 upon a minus 1 upon a plus L. So that becomes f is equal to g capital M small m upon L. LCM is a into a plus L. So a plus L minus a. So a got cancelled. This L got cancelled. So the answer remains is G capital M small m into a plus L. This is the answer. This is the answer. F is equal to G mm upon a into a plus L. G mm upon a into a plus L.
Excuse me, sir.
Yes.
Sir, could you please explain from the limits part?
First you note this, then I'll be talking about limits.
Okay, sir.
Noted?
Yes, sir.
Everyone else noted? Okay. Now pay attention. I'm using red color. When you are starting from this, when you are going from this point M, the first element you are getting at x is equal to a, right? And the last element which you will be getting will be at x is equal to a plus L. So what should be the limits? Limits will be from a to a plus L. Limit will be from a to a plus L. Understood now?
Yes, sir. Thank you, sir.
So that is how your limits are decided. Okay?
Please repeat
Understood,
what
everyone?
you just said.
I just said that the first element which you are getting when you are starting from small m. So first element you are getting at x is equal to a, and the last element on rod you will be getting at x is equal to a plus L, because your entire elements are on the rod, and the minimum distance of rod from mass m is a, and the maximum distance of rod from m is a plus L.
Okay,
Understood
sir.
now?
Understood. Yes, sir.
Yeah. So my suggestion to you all is to revise this question once again after the class. Okay. And solve the other question also which I have given as homework after the class. And we'll study further in next class. That is enough for today. Okay. Okay, everyone. Thank you so
Yes,
much.
Thank you, sir.
Okay,
thank
beta.
you, sir.
Thank you, sir.
Okay, beta.